7. Three Gorges Dam, $30 billion. The Three Gorges Dam doesn't just generate electricity, it controls the Yangtze River itself, creating a reservoir so massive it altered Earth's rotation by changing how water mass is distributed across the planet. The dam's 22,500 megawatt capacity exceeds the power generation of entire countries, while its flood control systems protect millions of people from natural disasters that previously devastated the region annually. But the dam's true achievement lies in engineering that required moving entire cities and relocating over 1 million people to create the reservoir. Chinese planners didn't just build a dam, they redesigned human geography across hundreds of miles, constructing new cities, transportation networks, and economic systems to replace what the flooding would destroy. The construction process involved pouring concrete continuously for over a decade, using materials sufficient to build multiple skyscrapers while maintaining structural integrity that can withstand earthquakes, floods, and pressures that would destroy conventional dams. The spillway system can discharge water volumes equivalent to entire rivers, using energy dissipation techniques that prevent downstream erosion. Environmental considerations included fish ladders, sediment management systems, and water quality controls that maintain ecosystem health, despite creating an artificial lake larger than some seas. The project's environmental impact studies influenced international dam construction standards, while demonstrating that massive infrastructure could coexist with environmental protection. The dam's completion transformed regional economics by providing reliable electricity to hundreds of millions of people, while creating shipping channels that opened interior China to international commerce. River transportation costs dropped dramatically, while flood damage, previously costing billions annually, became manageable through controlled water releases. Western engineers who studied the Three Gorges project admitted it represented organizational capabilities and political will that democratic governments couldn't replicate, requiring coordination between multiple agencies and sustained commitment across decades that election cycles typically interrupt. But while Three Gorges controlled water, the next project tackled something even more fundamental: controlling the desert itself and making it bloom. 6. South to North Water Transfer Project, $79 billion. The South to North Water Transfer Project represents the largest water engineering project in human history, moving water across distances equivalent to transcontinental shipping, while maintaining quality standards that exceed natural river systems. The project consists of 3 separate canal systems spanning over 2,800 miles, transferring water from southern China to arid northern regions through engineering that required solving problems on continental scales. But this wasn't just about moving water, it was about fundamentally altering China's geography and agricultural capacity. The eastern route alone can transfer 14.8 billion cubic meters annually, enough to supply major cities while supporting agricultural expansion in regions that were previously desert. The project essentially creates artificial rivers where none existed before. The engineering challenges involved building aqueducts across mountain ranges, under existing rivers, and through urban areas without disrupting existing infrastructure. Construction required tunneling through rock formations using techniques adapted from subway construction, while maintaining water flow that operates like circulatory systems across thousands of miles. Water quality management systems ensure that transferred water meets drinking standards despite traveling through multiple climate zones and geological formations. Treatment facilities positioned along the routes remove pollutants while adding minerals, creating water quality that often exceeds the original source standards. The project's completion transformed agricultural capacity in northern China, supporting crop production that feeds hundreds of millions of people, while reducing dependence on increasingly unreliable rainfall patterns. Urban water supplies became sustainable in cities that previously faced chronic shortages, supporting economic development that wasn't possible before reliable water access. Construction coordination involved multiple provinces with different economic priorities and environmental conditions. Yet the project maintained unified technical standards and completion schedules through central planning that democratic governments struggled to replicate across such distances and timeframes. Environmental monitoring systems track ecosystem impacts across the entire network, ensuring that water transfer doesn't damage source regions while supporting sustainable development in destination areas. Although the water project conquered geography, the next megaproject took on something even more ambitious, conquering space itself and bringing the benefits down to Earth. 5. China's high-speed rail network, $300 billion. China's high-speed rail network doesn't just connect cities, it has fundamentally reorganized how 1.4 billion people live and work, creating a transportation system so extensive and efficient that it makes flying between most Chinese cities pointless. With over 25,000 miles of track supporting trains that routinely operate at 200+ miles per hour, China built more high-speed rail in 2 decades than the rest of the world combined in a century. But the network's true innovation lies in precision timing that makes Swiss watches look imprecise. Trains departing every few minutes maintain schedules accurate to within seconds across journeys spanning thousands of miles, using coordination systems that track thousands of trains simultaneously while optimizing routes in real time based on weather, passenger demand, and maintenance requirements. The engineering required building tracks across every conceivable terrain, through mountains using tunnels longer than most subway systems, across rivers on bridges spanning distances that impress even bridge engineers, and through cities using elevated systems that minimize noise while maximizing passenger convenience. Construction maintained standards so strict that track alignment cannot vary by more than millimeters across hundreds of miles. Station design creates passenger flow that eliminates bottlenecks while providing amenities that exceed airport standards. The largest stations process more passengers hourly than most airports handle daily, using crowd management systems that prevent delays while maintaining safety standards that exceed international railway requirements. The network's economic impact extends far beyond transportation, creating development corridors that support urbanization patterns impossible without high-speed connectivity. Cities previously considered remote became commuter destinations, while economic opportunities spread from major metropolitan areas to smaller cities through reliable transportation links. Construction employed technologies adapted from aerospace engineering, including track systems that automatically adjust to temperature changes and weather conditions, while maintaining ride quality that allows passengers to use laptops and read comfortably at speeds exceeding highway travel. High-speed rail conquered land transportation, but the next project aimed even higher, literally reaching into space and bringing cosmic resources within Earth's grasp. 4. Tianwen Mars Mission and Space Station Program, $50 billion.